Alrighty, good morning, good afternoon, good evening. So we're just going to continue on from that last video. So we were talking about multiplicity, and we're going to practice that here. So we did one where it was, the multiplicity was odd for everything, so it's real nice and simple. So let's look at one where we have some even number. So if we look here, we have x squared times x plus 3 to the third. So what we're going to have to do is we're going to have to find our x's. So, or find our zeros, find our roots, find our solutions. So I need to set each thing to 0. So I have x squared equals 0. And if I look here, I have x plus 3 to the third. So when it means to the third, it means I just have x plus 3 times x plus 3 times x plus 3. So I can actually write that out 3 times just to really show this. And x plus 3 equals 0. Okay, so let's start with the x squared equals 0. So really, x squared is just x times x, right? So I can have x equals 0, or x and x equals 0. So I can say x equals 0 and x equals 0. So that's the same thing as if I could square root that x squared, and that would also give me 2 solutions, right? Because 0 times 0 equals 0. So either way you do it, I just like to look at my exponent and I see, okay, that's how many times the x is going to be there, or that part is going to be there. So the x squared just means, all right, I'm going to have 2 x's there. And then real quick, x plus 3 equals 0. For all 3 of those, we're going to do the exact same thing, just minus 3. And that's just going to give us x equals negative 3. So I'm going to draw a quick little graph. And 1, 2, 3, 0. Okay, so we know there's only 2 x values that we have here, 0 and negative 3. So what we have to do now is decide, all right, is it going through? Is it bouncing off? Is it, and then we have to find our end behavior and everything. So let's start off with our end behavior real quick. So end behavior, well, actually, in order to find end behavior, we have to find our degree. So if we look here, the way we can do that is by our exponents. So really, I have an x squared here, right? And then an x plus 3, an x, and an x. So what you can kind of do is, since these are all multiplying, what we can do is do x squared times x times x times x, which is x to the 1, 2, and 3, 4, 5. So my degree is 5. Now for turning points, it's going to be 1 less than that. So I'm going to have 4 turning points. And then last but not least is my end behavior. So it's 5, so I know it's going to be a down up. So we're going to start by doing that. So we have 4 turning points. So if we look, so now what we have to do is we have to look at our x-intercepts. So we have x, 0, x equals 0. So 0 happens twice. So that means we're going to bounce at 0. And at -3, it's 1, 2, 3 times. So that is an odd number, so it's going to go through. So, again, this is all just rough sketch. So I'm going to go through, and I go through -3. So 1, 2, 3, 4. Now, so I went through -3, went through -3 here, went up, had this, turning point 1, turning point 2, and we said it's going to bounce at 0, so I turn it right back around, and then 3, 4, and then it goes up. So, if we really wanted to, we could do like a table and plug in specific numbers and find more precise numbers. But like I said, this is just a sketch. It's just to get an idea. It's more just, I want to make sure that we know how to find the behaviors at the x-intercepts, and then just practicing with the degree and the amount of turning points. So let's try another one. We have x plus 2, x minus 1, x minus 3. Oops. Alright. So we look at this one. It's not too bad, right? We have, if we set these all to 0, so really I would know x plus 2 equals 0, x minus 1 equals 0, and x minus 3 equals 0. And those are pretty easy to solve. X equals -2, x equals 1, and x equals 3. So if we look real quick, do any of these have repeating numbers? Do any of these numbers repeat? They don't. So they all have an odd multiplicity, which means we're just going to go through each one. So I got to find my degree. I have x here times x times x. So x times x is x squared, then times x again is x to the third. So that means my degree is going to be 3, which means my number of turning points will be 2. And last thing is end behavior. If it's 3, that's going to be a down up with everything going through. So I'm going to make my x-intercepts at -2, 1, and 3. And sure enough, we go through, we're going to go here and there, there, and there. And if I see I have a turning point here and a turning point there. So I have 2 turning points. I have my up and down or down up end behavior, and I also have my x-intercepts at -2, 1, and 3. So this fits the description. Same thing like last time. If you really wanted to, you could find the y-intercept here. But again, this is just a sketch. We're just here for the idea. So if anybody had this problem, any math teacher had this problem, and you showed them this sketch, they'd be like, yeah, that looks pretty good. So let's do one last example. We're going to do x minus 2 times x plus 7 cubed. So there's a pattern. If you guys haven't seen it yet, you may have. If you did, great. If not, I'll kind of explain it a little bit. So first, when we factor this out, or when we set everything equal to 0, we have x minus 2. And then we have this x plus 7 cubed. So how many times do you think we're going to write out x plus 7? That's right, it's going to be 3 times. X plus 7 equals 0, x plus 7 equals 0, and x plus 7 equals 0. And then we just solve for x on all of these, which these are all nice and simple. And you only got to move one number. So x equals 2, and then x equals negative 7 3 times. So now we're getting to the part where I want to show you the little trick. So finding the degree is probably the trickiest part out of all of this. So this is what I do. So I want to find my degree. So what I'm going to do is I see if everything is in parentheses. What I'm going to do is I'm going to look at the top of the top corner of the parentheses. I'm going to see if there's an exponent there. If there's no exponent here, it's really just 1, right? So I have a 1 here, and then I come over here, and I have a 3. So 1 plus 3 is 4. So my degree is to the 4th. Which means my turning points, it's always the degree minus 1, which 4 minus 1 is going to be 3. And then with end behavior, if it's 4, x to the 4, that is going to be an even numbered, and it's positive, so it's actually going to be an up. And then let's look at our solutions and find our multiplicity. So 2 only shows up 1 time. So since that's odd, it's going to go through. And then negative 7 is 1, 2, 3 times, so that's also odd. So it's also going to go through. So 1, 2, 3, 4. Okay, so we know it's going to be up. Okay, and we said negative 7, positive 2. So, and then we have 3 turning points. So I'm going to go 1, 2, 3. Let me fix that. So it'll kind of have a W. So again, it's a sketch. It's not perfect. It doesn't have to be. But there's a couple key points that we want to make sure we have. We have our end behaviors, the up. We have the up and the up. We have our solutions, our x-intercepts, negative 7 and 2. And then we have our 3 turning points. We have 1, 2, 3. Alright guys, so that's going to conclude the practice. And we're just going to have some IXLs that we're going to work on with this. So hopefully this won't be too difficult for you guys.